about is our Digital Frontiers speaking series starts again this month. So next Wednesday, the 26th. So it's in this classroom just like it was before. And the topic is Think Security. And it is from 6:30 to 8 o'clock. You can join it live. Like, you don't have to come in person. You can click on the WebEx link, and then you'll be able to watch and participate. And again, these are just different people from the field, from the industry. We bring in different, for those of you that haven't been, we bring in different people, right? The guests that are coming this month, Brian Darby, he is the one who I really have created these speaking engagements. So he's at a lot of them. He's the vice president at QTS Data Centers. And Viviana was actually one of, hi, Angelique. Sure. No, come on in. Viviana was one of my tutors and helped in the lab, and she got an internship with Homeland Security in the cybersecurity department. She's going to come and be one of our guest speakers. And then Greg Davis, he is a senior network administrator. He does a lot of stuff with network security, cybersecurity, and he's actually one of our teachers. He teaches our CNT140 class, which is Cisco security. Okay, that's for next week, next Wednesday. And then lastly, I want to share an opportunity with you all. The last year I've been working on building a class called CIS101, which was more or less requested by industry partners. And it's not designed for IT people. So let me start it by saying that. This class isn't really for people that are necessarily going into IT, okay? This class was designed for people that are going to be technicians in other fields, and they maybe need to know some IT. Example, an HVAC technician, somebody that works on air conditioners, heatings, even water systems. Those fields are kind of merging right now, because we see a lot of information technology, a lot of IT stuff like being built and embedded into these different systems. Nurses are another example. So we had a lot of companies that hire nurses that they're like, we need our nurses to know how to do basic things like some basic Word, some basic PowerPoint, some Excel, understand what an operating system is, understand how to do some basic troubleshooting, right? What a hard drive is, how to move files around. In addition to that, they were also looking for some basic soft skills. I will tell you that the number one thing, and I've probably said this already, the number one thing that partners say and employers say is that we need people that are communicative and can interact with the team and interact with customers and can send a good email and can do some, conflict resolution and problem solving and things like that. So the other piece of this class is that. So there's like a hardware side or an IT type side, and then there's a professional skills side to it. And what's really interesting about this class is we worked really hard to align it with the City of Phoenix requirements for entry-level jobs so that it can be badged, that you can get like a professional badge for this class. And you actually can earn up to 3 badges. So the first one is the Technician IT Fundamentals. For a lot of you, I think this part would be pretty easy because I'm assuming most of you are pretty handy on a computer because you're in this class, and so you've at least learned this much, right? Or you're learning this much. And then the workforce professional skills. And then if you get both of those, you get a third one, which demonstrates that you have those skills. And it's the City of Phoenix and really even the state of Arizona is starting to push this out as an industry recognized badge that you've got some basic skills. So I've got some scholarships available for this class. And the way it's a conditional scholarship. It's conditional. And what that means is that you don't pay up front. And as long as you pass the class and you pass both final exams, the one that aligns with the IT hardware and the one that aligns with the workforce skills, as long as you pass both of those final exams with an 80% or higher, the scholarship pays for the class. So it's like $306, I think. Okay. And anyway, I just wanted to, I'll put that in the announcements as well. The class is April 7th through May 30th. It is an online only class. It's asynchronous. However, it is not self-paced. You have due dates, you have to turn things in, you take quizzes and things like that. Again, on a scale of 1 to 5, right, where this is like a class that's like a 5, like we'll put this at the, like if you're gauging it against this class, for I would say it's like a 2, you know, on the level of difficulty and the amount of homework. It's not designed to be these enhanced skills. It's enough that a person getting an entry-level job can be functional and considerate and professional. Okay, Cody?
I took CIS105. It's not 101, it's 105.
Yes.
It's very similar.
Yes. This is lower than 105. Oh. Yeah.
Anything failed. It failed that attempt. You get 3 attempts.
Mm.
You could fail an attempt by misclicking.
Yeah. Yeah.
Right next to it.
Yeah. Well, we don't use Cengage. We use an open source, a free, something that's put out by Microsoft that's open source. So. Yeah, it's not like Cengage. Look, I don't want to say that this class is easy, okay? Because it isn't necessarily easy. It depends on what your skill set is, okay? But it teaches you. I'll give you an example. Like you have to make a little PowerPoint presentation. You have to learn how to take screenshots. You'd be surprised at the number of people that don't know how to take screenshots and then name them and save it and move it from one file to another. It is for those of you that have taken BPC 170, it's kind of like a little bit of BPC 170, a little bit of BPC 270, and a little bit of CIS 105, and then a little bit of CIS 102. It's like taking all, you know, like employers wanted all those things, but not as deep and in one class. So we're like, okay, I can do that. Okay, so this is the outcome of that. I will put it in there. If you have an interest in this, you have to email me because it's not a published class. You cannot find it in Find a Class because it is linked to a scholarship, and you have to go into a special system where we send out your enrollment. Okay, anyway. April 7th through May 30th. If this is of interest to you, then there it is. Okay? Yeah, you can put them on LinkedIn. You can put them on your resume. So if you think about it, it's not like the CCNA certification per se, but it is an acknowledgement that you've accomplished something. And again, it's starting to roll out to where it would be like a recognized badge. Okay, any local government office would, right? So state and city, Maricopa would be recognizing it, and probably the data centers, Intel, because Intel wanted this, different engineering companies. It was actually initially started by Intel and engineering companies because they said that their engineers weren't very good at like doing presentations and creating a PowerPoint and interacting with customers. So that's kind of how it started. So, I'm not really sure yet, but I think it's going to be something that grows. It's not going to ever probably be as big as the CompTIA A+, but that's the goal for this. I think Arizona for sure. Yeah, Arizona for sure. Although we are going off of another state's playbook, the way that they've done it. So yeah, let me just say one more thing, Joe. Okay, so last summer, the director of cybersecurity, the national director was here. Okay, one of the things that I don't know what the government's working on anymore. Okay, but I think this is still true. There is an initiative that the government jobs, okay, quit looking for people that have a bachelor's. I mean, not that they don't look, but that they don't limit, right? Because right now there's so many jobs. If you've looked for a job, how many of them say you need 3 years of job experience, you need a bachelor's degree, you need a master's degree, blah 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 blah, blah, right? Okay, so that isn't, all those jobs don't need bachelor's degrees. All those jobs don't need master's degrees. The government, hold on, I'm going to go to Joe and then I'll go to you. So there was a big initiative prior, right, in the Biden administration to go through the jobs. And they've actually done that. And they've removed the bachelor's requirements for jobs that really didn't need a bachelor's requirement. They said, look, if you need a basic IT job, you don't need a bachelor's. You don't need a master's, okay? Let's get people working. So that has happened, including along the states, okay? So Homeland Security here in Phoenix, Ryan Murray, the director of cybersecurity, they went through their jobs. They removed bachelor's degrees if they didn't really need a bachelor's degree. They removed master's degree if they didn't really need a master's degree. Okay, so then there was a push for there to be some other type of acknowledgement for hands-on skills, professional skills, which is around certificates, like what CCNA is, like what CompTIA is, and badging. Okay, so this is all kind of part of that movement. I don't know where, and honestly, I've heard the Trump administration say the same thing. I was listening to where they're like, they're working on rolling out, different job titles and things like that so that not everyone has to have a bachelor's degree. Again, who knows where it's going to go right now. But I think this is kind of a new thing, is that people don't have to go get a 4-year degree, but we have a way of acknowledging or recognizing or certifying that they've got some skill set. Johnny, let's start with you. Number 1. What's number 1? The header. Oh, we're looking at the Ethernet frame, right? Everybody? Ethernet frame? Okay. We got the header. Joe, number 2. Okay. Data. What else could I call this? Payload. And what else can it also be called sometimes? Someone will know. Okay, Rob, number 3. Okay, the trailer. Okay. Let me see. Does everybody have their monitors? Can you close your monitors? Close your monitors. Okay. All right, Joel, number 4. Yeah, this one right here, number 4. Right, when you're looking at that. It is. Yeah, it is. Yeah, this is like, so that's the breakdown, right? So number 1. Yeah, the specific groups, the specific section. What's it called? What's that section called? What kind of start? All right, Derek. Okay. So you were close, Joel. Frame start. Okay. Number 5. Joel, what's number 5? Okay. Did you read the module study? Okay. Get some money. Number 5. Yes. What kind of addressing? Okay, it is the destination and the source, but what kind of address? Yes, there we go. So it's the destination and the source, MAC address. Jonathan, number 6. Okay. And, the type. Okay, number 7, Cody. Fat cats don't eat free? let's see, FAT. So we have frame, start, addressing, and then T, the cat type. And then so you would be at cats. Does that ring a bell at all? Cats? Austin? Oh. Austin? Number 7? Okay, so this is the FAT, and then cats don't eat free. Okay, Joel, I'm back up to you. Number 8. If you miss this one, I might laugh at you because the answer's kind of there. Yes, is data. Also called, could also be called the what? The answer's there. The payload. Oh, okay. So I just want to remind everybody that last week I said this is one of those things you have to know. You have to memorize it, okay? In 150 right now, we are like tearing this thing apart because we are learning about VLANs and we're learning about stuff called BPDU guard and the Ethernet frame and VLANs. Like this, so like I tell all my 150 students, I'm like, do you remember when I told you how important it is to know the frame? This is why, because of this day today and this week. So I'm going to tell you all right now, right? I don't know if you're going on to CNT140 or not, but no matter what you do, this frame is going to end up being important. Next week, when you come into class on Monday, make sure you know it. Okay? And I'm not even asking you to know all the nitty gritty about it. I'm asking you to be able to fill in the sections at this point. Okay? But that's going to change. Like you have to start learning what's happening at these different places. Okay? So next week, I can tell you for sure, you're going to see this on your attendance quizzes. Right? So make sure that you get this down today and over the weekend. Okay, so we are at Fat Cats Don't Eat Free. We're at the E. And Joel, we just went to you. Do you know what the third thing is that sometimes people call number 8? No, number 8. So number 8 is the same thing as number 2, right? The data and the payload. There's another name that sometimes people call this. Yeah, for 8. So, okay, Nicolo. You are on number 9. Yes. Error detection. Now, there's a lot of layers that do different types of error detection, right? For example, in layer 3, the network layer, they have something called the time to live, the TTL. You know how when we've done pings, you see that little TTL at the end? So that's they're doing, the layer 3 is doing a type of error detection by counting how many hops it has to go. The transport layer, it does some error detection too. What's different is that they all do something a little bit different. Like this just counts the number of bytes at the start. It'll be like, okay, there's 1,100 bytes. And it sends that information to the destination. And that way when the destination, they're like, oh, okay, I'm supposed to get, did I say 11,000 bytes? 1,100 bytes. 1,100 bytes. And so the destination should be like, oh, I'm supposed to have 1,100 bytes. I have 1,000 bytes. I know that there's an error. It doesn't know what the error is. It can't fix the error. It can't even notify the source that there was an error. All it does is it drops that frame. Okay? So again, each layer does things a little different. And when you're asked about the error, the type of error detection or what layer we're talking about, you have to read the question carefully so that you know what layer it's at. Okay, so for example, the transport layer, it does the 3-way handshake, okay, and it can retransmit. So if you get a question that's like, oh, what layer has error detection and will retransmit? That would be the transport layer because you see that it retransmits. Remember, at this layer, layer 2, it doesn't have the capability to retransmit. okay? And then, Joe, F, frame stop. Okay. Does anybody know what that other word is that we were talking about? Sometimes that it would refer to it as? Yeah. It is. It's the packet. Sometimes people will refer to it as the packet. Now, why? Why might they refer to this section sometimes as the packet? Yeah. Exactly right. From which layer? Layer 3. Yeah, the network layer. Exactly. So sometimes it might be referred to as the packet because that was the last PDU to get encapsulated. Exactly right. Does everybody see that? So sometimes people will call it the packet. Okay. Gianni, which one of these sections would be associated with the sublayer LLC? Yes. Right? So this would be associated with the LLC sublayer. And why? Why is it associated with the LLC sublayer? It's a network protocol? Exactly. The type contains what network protocol we're using, right? So IPv4 or IPv6, the type. Okay, Derek, which one is associated with the MAC sublayer? The MAC sublayer does have to do with encapsulation because the MAC sublayer is responsible for encapsulation, but there's a section up there that actually relates to the MAC sublayer. So MAC addressing is different than the MAC sublayer. So the data link is divided into two sublayers, the LLC sublayer and the MAC sublayer. Yes. The control. Okay. So this is associated with the MAC sublayer. So what does, now when we're talking about a MAC address, right, we're talking about an address. When we're talking about the MAC sublayer, what does the MAC stand for? Media Access Control. Okay, so what layer is this helping? Layer 1. Layer 1. Because it's helping to control placement onto the media. Okay, now there's a bunch of other things that happen in here, QoS, which helps to control the way that frames are moving and the speed and which ones they get filtered. So it does filtering. So there's a bunch of stuff that happens here. Okay, let's see. Where am I at? Jonathan, can you tell me what PDUs are inside of number 8? And we already have one. We already know that the packet is inside there. What other PDUs would I find inside there? Well, this is the frame. I can't find the frame in the frame. Okay, so hold that thought, Jonathan. I'm going to come back to you. Don't answer the question. I want you to answer this question. So what would we find in there without telling me the PDUs? What can I think about to understand what's going in there? So, because I think I heard you say it. The upper layer information, yeah. So you're going to find the upper layer information in here, right? In there. Okay, so Jonathan, does that help you? You're going to find the upper layer information. So we already know you're going to find the packet. So what are the other PDUs that you would find in here? The segment, exactly right. And then what's the other one? Yeah, that's why it's called the data. Okay? The clue's in the answer. The clue's there, okay? Yeah, Derek, don't send pets for beer, right? So we find the D, the data, right? And that's the same thing, like don't. That's what the reason I do fat cats don't eat free, because the D matches up to don't send pets for beer. Although we could do send pets for beer. And we could say fat cats do eat free. Okay. Related a little bit to error detection, what is a frame forwarding method? Give me a frame forwarding method. Good help, Gianni. Cody, what's another one? So cut through, good job. Cut through. Does that give you a clue? So not cut through, but Austin? Fast forwarding. That is a type of cut through. Okay, what's the other cut through method? Somebody who's got the other cut through method? Rob.
I call it store and go.
That's not a cut through method. So store and forward is another frame forwarding method. That's actually one I was looking for store and forward, okay? So store and forward, and then there's cut through and store and forward, and we've got two types of cut through. Fast forward, and then there's one more that I'm looking for. Fragment free. Okay, fragment free. The way that a frame gets forwarded is determined by the switch. And the way that the switch does it is determined by the network administrator. Okay? There's a default frame forwarding, which is actually fast forward switching is default on a Cisco switch. Okay? However, as the network administrator, if you wanted to, you could go in and configure it to be different. Okay? Which one has the highest latency? Which one's the slowest, in other words? Raise your hand answer. Austin. Yeah, store and forward is the slowest. And you can kind of process this, okay? With store and forward, what happens is it says, you know what? Quality is really important to me if I'm the switch, okay? And I'm a store forward. And what that means is I'm going to wait until I get all of the frames built up, and then I'm going to forward it because I want to make sure I've got all of the frames before I forward it, okay? And so that slows it down because it has to gather them all up, okay? They have to gather them all up. Now, what's the difference between cut through, fast forwarding, and cut through fragment free? So store and forward does have an error detection. That's why quality is so important, right? So store and forward has error detection. It does a frame check sequence, okay? And then the next question is, if we're talking about these cut through methods, I've got fast forwarding and fragment free. Joe, what's the difference between fast forwarding and fragment free? You're thinking of buffering. Which we're going to talk about next. Yes, okay. I'm going to come to you for the next one, Austin. Okay, so with fast forwarding, what it does is it looks at the frame start, which we've got the preamble and a bunch of stuff in here. And remember, in a frame, we list the destination first. The reason we list the destination first is because of this fast forward switching model. What it will do is it will read the destination address and it will immediately forward it. It doesn't bother to read all of this other information. It's like, I just want to get this going to where it's supposed to be. I don't know about you, but this is kind of the way I drive. And what I mean by that is if I'm running late or if I'm running right on time, I know that I have to go to the East Valley. I just get on the road. Right? I just get on the road. I'm like, well, when I get to a stop sign, or I'll pull over and then I'll put the address in, right? So I just kind of get on the road. Now, Austin, fragment free. What's that one? The whole frame is store and forward. So fragment free, does anybody have what that one is? The first 64, is it bits or bytes? Bytes. The first 64 bytes. I think it's the first 64 bytes. It sends the first 64 bytes of information. Research has been done that shows that if the first 64 bytes of a frame are correct, chances are the rest of it is correct. And so it doesn't even bother to read any more past the first 64 bytes. Okay? Just reads the 64 bytes and then it forwards it. Okay, let's see. So Joe, you were talking about buffering. You want to explain what buffering is?
One of them was a Q and one was a pole.
Okay.
And I was the names.
So we've got a switch right here. And this switch needs to communicate with another switch. Okay, or on the destination. So maybe here's source and here's destination. And if there's a bottleneck, right, there's two types of buffering. What are they called? Port-based. And what was the other one? Okay, so I think that's what you meant by the queue, right? This, where it queues up on the port. And the other one, what did you call it?
I didn't call it anything. I didn't remember the names.
I know, but you kind of described a pool, right? Okay, so yeah, because I thought that was a good way to describe it. So with port-based, it actually just sits on the port. That port has a little memory inside there, and it can hold on to the frames until it can sense that the other device is available. Because remember, CSMA, carrier sense, right? The switches can sense the media, Now shared means that I've got like a little basket over here, and I can just, any of these ports can share and store the information until it detects that the destination is available. Then it puts it back on the port and it sends it across, okay? All right, what else can you add? Who read the module? Can you raise your hand if you read the module? Okay, almost all of it. Okay. Reviewed the PowerPoint. Okay. So when you come back next week, make sure you've done that, because things just start to kind of get faster from here on out. Okay. And having a two-way conversation or a one-way with 15 of you is more rewarding. All right. Okay. Let's take a break. What time is it? It's 1:52. Come back at 2:01. Okay, come back at 2:01. What is the process of encapsulation? Somebody raise your hand. Or I can call on you. Jonathan, what's encapsulation? Okay. Yep. Instead of saying covers it up, can I use the word wraps it up? Like if you think of encapsulating it, right? Like a cocoon, like a worm cocoon, right? It's wrapping it up. Okay. All right. What is the first? What's layer 7 of the OSI model, Joel? Jeez. Layer 7. No.
That's the top one, right?
The top one. Oh my gosh.
That's what I'm saying.
All people seem to. Does that help you?
Session is 5.
You were right. Session is 5. Oh, that's a good clue. What do you download from the store? From Google Play, right?
Application.
Thank you. Application. Okay, George, what's the next layer? Nicolo. Session. Austin, layer 4. Layer 3. Network. Layer 2. Data link. Joe, layer 1. Physical. Okay. You can turn them back on, but this is stuff you all should know, right? So good job knowing it. Yeah, you can turn it on. You can turn it back on. We're going to talk about how a switch builds a MAC address table here in a minute. Okay, so let's see. We've got our layers. Okay, and then we said that the process of encapsulation is when these layers get wrapped up, right? They get wrapped up. And we've got an example of a few of the different types of protocols that work at each layer. DNS, HTTP, point-to-point, email, SMTP at the application layer for our presentation. If you can think about anything that would present us something, HTML, XML, JPEG, MP3. This is, I don't know what, sockets, as in secure sockets, because it's presenting it to us securely, okay? Encryption is happening here. Then we've got session layer. Now this says session establishment. Do you see how it says TCP? Basically, TCP is a protocol that works at the transport layer. However, in order for TCP to work, you have to have a session so that you can do the three-way handshake. RTP, RPC, we don't deal as much with these protocols as we do with the transport layer, the network layer, the data link layer, and the physical layer in the field of networking. And then we've got the transport layer, TCP, UDP, SSL. Remember, SSL works with actually all of these, the session layer and the presentation layer. They're helping. The network layer, we have IP, so we have IPv4, IPv6, IPsec, ICMP, neighbor discovery, router advertisements, router solicitations, like a bunch of stuff is happening at the network layer. The data link layer, hey, that's the one we've been working on right now. And then the physical layer, all right? And so what happens? It moves down the OSI model, then it crosses over on the channel with the help of the media access sublayer, and it gets to the other side, right? And then we've got our protocol data units, PDUs. We've got the data, and then this one gets wrapped up. And what does it pick up right here at the transport layer? What is this picking up when it's getting encapsulated? What is it? It is called the segment, and it picks up, yes, it picks up the source and the destination port, okay? It picks up the source and the destination port. Now this is called the segment. It moves down to the network layer. What's it going to pick up at the network layer? Yeah, it picks up the source and the destination IP address. And what do I call this now? Packet, right? Did it work, Pam? Oh, cool. Okay, it's called the packet. Now, notice again, it's moving down. We get down to the data link layer. What is this PDU called? It's called the frame. Okay, now that's what we've just been working on, right? So this gets wrapped up, encapsulated, and it picks up the header and the trailer. Everything from above is in here. Okay, now what sublayer is actually responsible for the physical encapsulation? What sublayer? The MAC. The MAC sublayer does the encapsulation. It adds the addressing. Okay, now what layer is this working at as far as what we understand for LANs and WANs? The data link layer, is it LANs or WANs? LANs, right? Local area network. So here, these devices, when they're communicating with each other, LANs, okay? The network layer, that's when we're talking more and starting to move across networks, WANs. Then we move down to the physical layer. What is the PDU called? It's called bits. And then what is the process that happens that allows us to take the bits and put it onto the media? Rob, what's that process called where we take the bits from the physical layer and we put them onto the media? What's that called?
Process where you put bits on the media.
Yep. Like it happens at the physical layer. It's not encapsulation. The other E word. Don't say it, Joe. Don't say it, Derek. Huh? Joel? You got to get one right today. Oh, you did get application right. So you got to get a second one right today. E. So we're at the physical layer, and we're at bits, and we've got to get it down onto the channel. Niccolo. No. Johnny. Encoding. 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 Does that all sound familiar? Okay.
And then the codes in the other one.
Okay. So the bits get encoded. Okay. So this is all happening, right? And then, so we want to talk about how a switch uses the frame. So there we've got that fat cats don't eat free, right? There's a nice little easy way to remember it. If you have a better, what are those called? Mnemonics? Let me know, because we could add that. We could get a new mnemonic. Okay, I want to talk about a few things as it relates to the frame, okay? What is if I send a message unicast, what does that mean? Derek. One-to-one. Me sending a message to you, you sending a message to me, right? Okay, how about multicast? Get some money. Yeah, me to a group, right? You to a group, multicast. Okay, and then what about broadcast? Huh? One to everybody, yeah. One to everybody, right? One to everybody. So broadcast. Now, what I want you to think about is with addressing, there are multicast IP addresses, and they always will start with a 224, between 224 and 239, okay? A multicast IP address. Right? So a multicast IP address might be like 224.100.10.1. And it would go through the 239s. I think it's I might even be wrong. I think it's 239, 255, 255, okay? But that's a multicast IP address. Okay? Now, as the packet comes down from the network layer, it's going to get put inside this frame, okay? And remember, we've got this type over here with the IPv4 or IPv6. Well, one of the things that happens is it's got to figure out, A, is it IPv4? Is it IPv6? It also figures out if it's a unicast address, a multicast address, or a broadcast address, okay? And depending upon what it is, will determine the MAC address, okay, that's used when sending the frame. Because just like there is broadcast IP addresses and multicast IP addresses, there's broadcast multicast addresses, and there's multicast MAC addresses, okay? And so the frame has to make sure that it gets the right type of address in its header when it does that. So we're going to look at that. We know that this is helping the LLC. The LLC sublayer helps the network layer, layer 3. The control helps the MAC, right? Does encoding. All right, we do all that. Okay. So let's see here. If my source IP address is 10.205 and my destination IP address is a 224, what did we just say that a 224 would be? A multicast. And remember, that's inside here. That's inside here, right? Now the frame, it doesn't really know what to do with anything based on the IP address. It only uses MAC addresses. Everything at layer 2 just functions with MAC addresses. But what it needs to do is it has to have a special destination address in here, okay? And what I want you to make note of is that the destination MAC address starts with 01005E, okay? 01005E. Now, if it's an IPv6, it starts with something else, and frankly, I don't remember. We could look it up. What is it? FF00. Thank you. Good job, Joe. FF00, right? Is it still a 5E?
No, I have like two semicolons.
So what's this one right here equivalent to? FF00.
And that has like two semicolons.
Oh,
With a zero, probably zero.
FF. Oh, for the multicast. Okay, yeah. Right, for the multicast. No, you're right. Yeah, no, that's what I'm talking about. I just thought it started with something different. Oh, wait. No, this is the multicast for the IPv6 address, not the MAC address. Not the MAC address. It's something else. Okay. So what I want everybody to do is I want you to open up your command prompt. Okay. And I want you to I want you to type ARP-A. Okay. Do you see a 01005E on your output for ARP-A? Yeah, can you raise your hand if you have a 01005E somewhere? Okay, raise your hand. Everybody does, right? What that means is that we're part of a multicast group. Okay, we're part of a multicast group. And we're actually part of a few multicast groups, right? So we can see here what the IP address is, 224, and then what the corresponding MAC address is. Why is this called a physical address? Joel?
Because it's imprinted onto the actual device and it doesn't change.
Okay, what would that, when it's imprinted on the hardware side of it, that's called a burned-in address. And yes, it takes it from that and puts it in here as the physical address, right? What are some of the names that we can call a MAC address? So we just said it can be a MAC address, can be a physical address, burned-in address. What else? Anybody? Hardware address. What else? What layer are we talking about? It's not layer 1. Data link address. CAM address, yes. Okay, again, you got to know all these different terms because it always is something different, right? It's always something different. So hardware address, burned-in address, physical address, layer 2 address, data link address, CAM address, blah, 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 blah. Okay. Now, this is our destination, okay? And we know that 01005E, that means it's a multicast. What is FFFFFF? A broadcast. Okay? So if a broadcast message needs to be sent out and it sees a broadcast address, then the corresponding MAC address will be all Fs. Okay? Now, this is important because next week we're going to do a lab and you're going to be looking at the MAC address table. All right? And we're going to go through the MAC address table today and talk about how the switch functions to learn MAC addresses. And it's important to see these relationships, okay? Now, I just did ARP-A. What kind of table is this? So that command is ARP-A. What kind of table would that be? Don't overthink it. It's not IPv4. It's an ARP table. Yeah, it's an ARP table. This is an ARP table. Right. So what we're looking at is an ARP table. Now, here's something to think about. Module 6, 7, and 9 are all related to each other. If you remember, I think last week I mentioned how Cisco does something weird and they put like module 8 in between, which doesn't make any sense because module 8 is all about layer 3. ARP is a layer 3 protocol. However, it bridges layer 2 to layer 3. And I think that when you look at the ARP table, you can see that, okay? Because the physical address comes from what layer? Everybody? 2, the data link layer. And IP addresses come from what layer? The network layer. So ARP, although it is a network layer protocol, it is bridging the gap between the data link layer and the network layer, okay? Yes. Okay, so we're going to do that next. Let's see, Rob, can you tell me what your IP address is? .234. Okay. Now, does anybody see the .234 in my list of addresses up here? No, right? That means that currently my computer does not know how to talk to Rob's computer. Okay? However, if I want to, I can talk to Rob's computer because it's on the same network. So I'm just going to send a ping. Okay? Now, if I do the ARP-A again, will I see Rob's address in there? I should, right? Okay. Did I do an ARP-A? Hold on. Oh, yeah, there it is. Nice. Okay. There it is, 10.204.172.234. Okay. Now, would you take a look at your physical address and tell me, is it A4BB6D 86DEAL? And I don't know if it's looking at your VM address or your actual desktop address. Is it the desktop? Yeah, okay. So you can do an IP config all. Okay. Did you find it?
Yeah.
And is it the A4BB60 86DEA1?
Yeah, A4BB6086D-A1.
Okay, so everyone sees that, right? Now, how did it learn it? Did it learn it dynamically, or did I have to statically go and bond and marry those together? No? Well, so if you look right here, it says dynamic. So my computer dynamically learned it by pinging. If it was static, I would have had to go into the GUI and I would have had to know your address and I would have had to add it statically. These have been built in the system by the network administrator. They're static, okay? They're static. Okay, let's see, my IP address, yes?
Is there a way to ping every system on the network?
There is. There is. There's a broad, you know what? Hold on. I'm gonna look it up. I think we can ping the broadcast and it might work. But let's not do that. Because what that will do is it could trigger our IT people that we're doing something nefarious. So let's not do that. There is a way to do that though, but I think it might trigger or something. Yeah. I mean, they probably know it's me, right? But okay. So here's my address. So I want everyone just look at your ARP table and see whether or not you have my address in there, the .83. Yes, Derek.
This is the same way they do the MAC addressing table, MAC address table, because it can designation store it. And
Yeah, we're going to talk about, that's where we're moving to. That's where we're moving to. Yeah. Okay. Does anybody have my address? Okay, so go ahead and ping my address. Ping my address, which is the .83. Okay, so you're going to ping 10.204.172.83. And then go check your ARP table. Okay. All right. Do you see my address in your ARP table? Okay. Derek, what's your IP address? So do an IP config to find your IP address. .204, okay. So it's 10.204. Okay, so notice you all have pinged me, right? But I didn't ping you. However, when you pinged my device, it allowed my device to also learn about your information. So if you look up here, you should all see your own IP address in my ARP table. So can you just verify that? Okay. So they're all talking. Everybody see their IP address? Okay. Now, do you remember what layer did I say ARP works at? It's associated with primarily. 3. It's a network layer. So ARP is a network layer protocol that helps the data link layer. Okay, it helps the data link layer. Now, on this device, this is a computer, right? And we see the ARP table. On a switch, what kind of table would I see? A MAC address table. A MAC address table. You can actually see an ARP table on a switch, but it's not able to do anything with the ARP table, okay? But if you do it on a router, then yes, you're going to see ARP, okay? And the reason is because it's functioning at layer 3. A router functions in at layer 3. And do you remember when I said that the brains of this and the brains of the router are similar, and that's why you would use a crossover? This is partly why. Computers are really considered more like a layer 3 device, that they're functioning more like a network layer device, okay? And this is part of the reason why, ARP and the way that they encode information, okay? All right, if I were to ask you a question that says, look at this frame, and you see 01005E, what would you be able to tell about that frame if you saw that as the destination? So multicast, that you would know that that frame is destined for multicast. Okay, so you want to be able to start putting together some of these pieces. Okay, you want to be able to put together some of these pieces. Okay, so do we see how that kind of works right now then? Okay, see how that works? All right, now what about this one? Broadcast, right? It's broadcast. What we know then is that the IP address that was inside here was destined to a broadcast. Destined to broadcast. Okay, now I want you to think about the addressing, right? So you want to start pulling all this together. We started figuring out network address ranges last week, right? Where we figured out what the network address was. And what was the definition of the host bits for a network address? What are all the host bits are what for a network address? They're off. They're off. Okay, now what about the first usable address? All of the host bits are what? They're all off except the last one. Okay, and then we also said, what is the definition of the last usable address? All on except the last one. And what about the broadcast address? All on. Okay, so do you see, if we see a broadcast address inside the packet that's a broadcast, then that affects the destination address inside the frame, okay? Even though it seems like we might be learning about different topics within networking, right? They all relate back. They all relate back. And I want to try and draw that, how they all relate back, so that you can link them together, okay? And that's how. Make sense? That's why we have to know and understand the address ranges. You might be called upon to look inside of a frame, look inside of a packet, okay? Troubleshoot something, figure out why a end device isn't working, why a router isn't working, okay? Well, you want to be able to understand the relationship of addressing to the different PDUs and the different layers of the OSI model. Am I getting through? Okay. All right. That is address resolution protocol, which is module 9. Again, weird. Next week, you're doing module 8 and 9, okay? 9 is a very short module, and we will have talked about a lot of it today, all right? We will have talked about a lot of it today. On the IPv6 side, it's called Neighbor Discovery Protocol, okay? ARP and Neighbor Discovery Protocol, they do the same type of job. It's just that one functions at IPv6 and the other one is for IPv4. And that is Neighbor Discovery, okay? Because when Rob pinged my address and when you all pinged my address, what was happening? ARP was happening, and ARP is discovering the neighbors. ARP is going out there and learning about the local area network. That's what NDP does, Neighbor Discovery Protocol. It's learning about the IPv6 neighbors. Okay, computers and routers keep track of ARP. Computers and routers keep track of NDP. Okay. Okay, so we're going to take a look at this MAC address table and see if we can answer some questions about that. All right. I want to make sure that everybody writes down their, go ahead and do an IP config all, and just have your hardware address handy, your physical address handy, okay? Everybody have their physical address handy? Okay. How does a switch, or when does a switch learn about MAC addresses? Because a switch keeps track of MAC address tables. What does a router keep track of? Joe, yes, they do. But relative to the conversation we had today, what does it keep track of? ARP tables. Okay, but you're right. So module 8, we're going to learn about routing tables. Okay, routers have a lot of jobs. They have a lot of jobs. That's why they're expensive, right? And one thing, they keep track of route tables, which you're going to read about in Module 8, but they also keep track of ARP tables, which is what we just went through, okay? Computers and routers keep track of ARP tables, and switches keep track of what? MAC address tables and MAC addresses, okay? And did anybody answer the question I asked? When does a switch learn about a MAC address, Austin? Is it sending? So can I reword that? It's when a frame goes into the switch. Is that what you mean? Like, right. So like if I am going in there, right? So then F06 will learn about that MAC address and record it. Now, when did you see that happen? The last lab. The last lab, okay? Now, the point of the last lab was to learn how to do an in-band connection. And how did we do that? Like, how'd you set up an in-band connection? What did you have to set up? Austin? You had to, not the console, you had to set up the virtual interface, the SVI, the VLAN. In that lab, though, it also had you look at, I think, the MAC address table, right? And the reason is because it was preparing you for the lab that we're doing next week and for this conversation, okay, around the MAC address table. So you had your first look at a MAC address table last week, and then you'll be getting another look at the MAC address table next week, okay, in Lab 755. Okay. All right. So PCA, this is its MAC address, AAAA, and PCB, right? Okay. So let's just imagine that they're connected. Now let's look at this. Now this is a router. Okay, so we'll not look at that one yet. This is the setup that we have. We've got switch 1 and switch 2. So switch 1 is on F010 and switch 2 is on F01. Okay. Does everybody see that? Okay. And if PCA wants to talk to PCB, it's got to send a frame up there, okay? Now, PCA, let's call this, Rob, give me your address again, 10.204.172.36? What was your IP address? 234, okay, and then, Joe, what's your IP address?
10.204.172.135.
Oh, look at how convenient that is, 135, okay. Since computers function mostly at the network layer, they know about their IP addresses, but they don't necessarily know about the other MAC addresses. So it has to find that because these devices don't use IP addresses to talk to each other. What do they use to talk to each other? MAC addresses. They use MAC addresses. Okay. How many of you have done a ping and the very first reply failed? Okay. Why did it fail? Okay, think about that. So based on what we've learned so far, why might that first one have failed? Joel, you got a guess? Right.
So that's the first to establish it, and once you ping again, it recognizes the address.
Which address?
The one that you did the first time.
Okay. So is it the IP address that it doesn't recognize or the MAC address? It's the MAC address. Yeah. Okay, so whenever you ping, if the first one fails, that's because it has to do an ARP request first. Because these devices know their IP addresses, and they even know the neighbor's IP address, but they don't necessarily know the MAC address, okay? Now, why didn't Rob's first ping to me fail, or my first one to Rob? I don't remember who pinged. Why didn't that one fail? Actually, we didn't. Do you remember your address wasn't in my ARP table? Exactly. That, and the other reason could be is we were so close that it beat the timer. It beat the timer. So it could have either already been stored in the MAC address or I simply beat the timer. Okay, I beat the timer. All right, so if PCA wants to ping PCB, it knows the IP address, so it types in there, right? It's going to do a ping 10.204.172.130. It's going to ping. So it sends up a frame. It hits F06. And now what happens? What happens? It's from here. Let's just walk through this. What's that? Okay. Okay. Even before that, what does it do? Like at the bare bones, what does it do? Even before it forwards the frame. So it receives the frame, and then up here we've got a MAC address table, right? We've got the MAC address table. So when it gets here, what's the first thing it does? It looks to see if there's a match. It looks inside the MAC address table. That's the first thing it does. Now, here's our MAC address table for switch 1 and switch 2. So right now, what does it see? If it looks at the MAC address table first, it sees nothing, right? Because it hasn't been communicating yet. I mean, it might see something, but it doesn't see the destination. Okay, now this is when it gets interesting. This is when it gets interesting. Since it doesn't see anything, what does it need to do next? Austin. Okay, but what does it flood it with? Okay, so remember, the computers know each other's IP addresses. What kind of a request? An ARP request. Okay, so this is again how what I mean is a layer 3 protocol, but it's helping the data link layer. Okay, there's no MAC address in here, which means PCA doesn't know really how to communicate with PCB yet. Okay, so what has to happen is PCA needs to send out an ARP request. An ARP request, okay? Has to send out an ARP request. Now, that ARP request packs up the information and puts it in a frame. Okay, so now an ARP request goes out. An ARP request goes out, okay? Now that the ARP request has gone out, it sees that there's nothing inside the MAC address, so it's like, well, I'm here to help. I'm here to help. I'm here to help. So when the ARP request comes into F06, what's going to get recorded in here? What's going to get recorded in the MAC address table? The MAC address from PCA. Okay? Even though it was an ARP request, it's going to go ahead and it's going to record the MAC address from PCA, because remember, a switch learns when a frame goes into it. When a frame goes into it, when a message or traffic goes into it. Okay, now let's come back to you, Austin. It doesn't see anything in there, and it's trying to find. It's got to get to 10.204.172.135 so that it can get its MAC address, okay? Now, I'm going to add a PC over here. I'm going to add a PC over here. And this is going to be you, Gianni. So, Gianni, give me your IP address. 10, what was it? 22. Oh, you're the dot 22. Okay. And give me, just give me the last 6 of your MAC address. Not the whole thing. Just give me the last 6.
81, 16.
Okay, 16. All right. All right, so now Austin, let's come back to you because you said it's going to flood it out all the ports, right?
Oh, it's 6.
Oh. 6
The 60 is a C.
C.
Yeah, and then 16.
Oh my gosh. Okay, there. 16. Okay. Okay. Austin says it's going to flood it out all the ports. Say that again. All of the active links. That's a very important distinction. Okay? And that is the kind of question that they put on the CCNA all the time. All right? CompTIA exams. It floods out all of the active ports. It doesn't flood out all of the ports. Okay? So let's say we've got 3 computers. It's going to send a message. Now, why is it flooding it out, Austin? Exactly. It's like, someone out there is going to know. Okay, so ARP request, ARP request goes out this active port. Okay, now it's coming into F01. What happens? Okay, so F01 will record, it's going to record 1A. I'm just going to do 1A. We know what that means, right? It's going to record that. Now, what else is it going to record? Say it again. PCA. It's also going to record PCA. And what's it going to record it on? What port? So it's coming in. Remember, it learns when it receives. So it's going to record it on port F01. Everybody follow that so far? So whatever comes in is when it's learning it. Whatever comes in, okay? But remember, we still have an ARP request happening right here. We still have an ARP request happening. Okay. Now it's looking to see if it has a MAC address for PCB, but does it? It doesn't, right? Does Gianni's computer do anything with the ARP request? What does it do with it? What does Gianni's computer do with it? It discards it. It drops it. It drops it. Okay, and let's see. Let's call this Rob's computer, and let's call this Joel's computer. Okay, what does Rob and Joel's computer do with it? Just drops it, right? Okay. Joe's computer receives it, and Joel's computer says what? Yay! That's my IP address. Yeah. It says, it actually says that's my IP address because remember, this is an ARP request, right? It's an ARP request. So this computer says, hey, yeah, that's me. And that other computer needs my MAC address because they're on my same network and they need to communicate with me. All right, so it's going to package up a what? Yep, and what kind of message is going to be sent? So remember, this first one was a what? An ARP request. So PCB is going to do an ARP reply. It's going to do an ARP reply. Okay, so it packages it up. It puts the MAC address inside the frame. Okay, here we are. It goes into F018. What happens? It records the MAC address, right? Because it's learning when it goes in. Okay, so it's going to record B, 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 B. And what port is it on, Cody? F018, right? F018. Everybody following so far? It's like creating a map. It's creating a map. And this is still the ARP reply and request. Okay, it's not really even the frame, the communication frame. Okay, now I'm ready. Okay, I'm going across because I'm still doing an ARP reply. Okay, I hit F010. What happens on switch 1? It records what? Okay, of what? Okay, so it records it on what port? Yes. So F010, it records I'm gonna do it like this. What else does it record? Switch 2, which is 2A. What port? Well, so it's going to record switch 2. It came in on, so what port does it record it on? 010. F010. Everybody see that? Yeah. Yes, but what happens when the switch so how long does a MAC address stay inside the table? It does that, but it also has a timer. So when does a MAC address purge out of the MAC address table? 5 minutes. So you can't really sit there and ping all the time. So you just leave your network to do it, right? Now, can I change that timer? So 300 seconds. Can I change it? Okay, yes, the answer is yes, I can change it. And why would I want to change it? Why might I want to change it? Yeah. Well, so let me ask you, in this room, would it be beneficial for the switches to maintain the MAC addresses for a longer amount of time? It would, because of, we're all sitting at the computer, we're working. Now, we don't change that here. We just let it do its job. But I want you to think of another scenario. What about Starbucks? Dunkin' Donuts. When you go in and you get on free Wi-Fi or their network, would you want to have MAC addresses in the table for a long time? 5 minutes, a short time? They could stack up really fast. So what would I want to do if I were the network administrator for Starbucks, maybe? Huh? I would want to decrease the time because I don't want my MAC tables filling up and having stuff in there for 5 minutes. Customers might not even be there for 5 minutes, right? Okay, so you have to think about things like that. All right, now, what happens if I add a router? Okay, let's add a router. So we've got this, right? So now we've got that. Oh, mess up on my thing. Okay. Hold on. I want to see if I can get my, let's see. I want that to be, can I move this over here and move this over here? I want to try to get that. Oh. Do I have it lined up? Am I going the wrong way? Oh, it's over here. Okay. Is it close? Oh, man. Okay. Well, I think we're just going to have to erase this, and we'll just erase it. What happens if I need to send information to a device that is not on my local area network? It's on another network. I know the answer, so I'm not going to answer it. Okay, can you explain that, Joe? Okay, so what is this right here? That's my default gateway, right? Has everybody got that? That's the default gateway. So let's give this, let's call this, so we'll do C, A, C, A, C, A. Okay. And let's just put another network over here with a computer, and let's call this a 192.168.10.2/24 address. Okay. So let's go through this process again and see what happens. Okay, so if PCA wants to talk to 192.168.10.2, so it gets money, what happens? So if PCA wants to talk to our device up there, the 192.168, and this was a 10.204.172.36, what happens? Okay, so it's going to do an ARP request again because this is empty, correct? Okay, so it's going to go into F06, and it's going to record the MAC address. Then what? What does it do next? So it doesn't see it in there, right? It doesn't have a MAC address for 192.168.10.2. What does it got to do next with its ARP request? Anybody? Would it go straight to the router? It would go to all active ports, right? The ARP request would go out all active ports. Okay, so does the ARP request go here? What happens here? It records the MAC address. So F01, it records the MAC address for this guy. 1A, 1A. Okay, and then remember we had some computers here. What happens with these? It goes here because they're active ports, and then what happens? They drop, right? Nothing happens. Okay, but it did get to learn about this. Okay, then what? So it went out active ports, now it's going to go out this port. What's going to happen? So this is the default what? Yeah, it's the default gateway. Okay, so it's going to come back from here, right? Because it's going to be like, oh, this address, 192.168.10, is that on my 10.204.172 network? It's not out of band, it's out of this network, right? So out of band is a term that we refer to when we're trying to get into a device. Not really, we're not talking about a remote network. That's more just when we're trying to get into a device. Okay, Austin, what happens? It doesn't, it will keep track of MAC address tables, but it doesn't really do it. Like, that's not its job. That's not its job. No, No, it doesn't need to because it can keep track of ARP tables where it knows the IP address and the MAC address, right? Because remember, an ARP table keeps track of MAC addresses and IP addresses. Okay, so what it's going to do is it's going to respond with what? An ARP what? An ARP reply. So it's going to come in here, and what's it going to do? Okay, on what port? G01, so it's going to record, it's going to, G01, and it's going to record that CA, 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 and then it's going to come down to PCA. Hi, Karina. Okay, now what happens? What's that? Now it can send the data because it knows. So now it can package up the data that it's trying to send to 192.168.10.2. Okay? So it's building a map. The data link layer and the network layer, they're working together to build a map so they can move the frames. And if they can move the frames, then they can get the packet to this other device. Okay? And the same thing is happening here because now the router has used its route table. Okay, it's used its route table to move that frame and that packet to this other PC over here. Let's call it PC1. And now it's going to do the same thing. PC1 is going to send a frame. Is it going to see anything in the MAC address table? Yes or no? No. If it's never talked to this one before, and it hasn't talked to the default gateway before, it wouldn't. So it's got to go through the same process. It's got to flood out all the ports. Okay. Then the router does its job and gets it over. Okay. Are we talking about this one up here? Yeah. Well, if it's trying to talk to this one down here, it also has to learn its default gateway and put it in the MAC address table so that it knows to send it to the default gateway. It will, yeah. Yeah, exactly right. So like if we had a bunch of PCs here, you're right, it would go out the active ports. Those ports, they'd be like, that's not meant for me. It would just let it drop. Austin? Yes.
My ping, let's say Google, and I go to the default gateway. That default gateway then has to obviously go to like a service provider. How does it know? Is it just shotgunning it across everything?
Not necessarily. It depends. So that's where we move into module 8 with the network layer. So what we didn't talk about is the route tables, okay? Because you're absolutely right. Like this could go to another router, which could go to another router. Once the ARP table has done its job, the route table takes over. Yes. Yes. Well, to another router. It'll go until it finds a router that knows the route, that knows where that network is. And sometimes, if there isn't one, it just goes away. And that's when you get an error that says, you know, router undetermined, unreachable, or not router, but unreachable, because it can't find it. There's no route table for it. It's Yeah, it's so there's a couple of things. So routers keep route tables with how to get to the next router that might know. And then that router, same thing, it's going to have route tables. There's also something called a gateway of last resort. And the gateway of last resort will say, okay, look, I'm going to just go ahead and kick this packet to the ISP. I'm going to send it to Cox. I'm going to send it to CenturyLink. And the reason is because CenturyLink probably has 100,000 routes. If anyone knows how to get there, CenturyLink would know how to get there. So it gets it to CenturyLink. Yeah. Just go, yep. Exactly. Something like that. Not exactly like that, but like that. Yeah. Okay. All right. Everybody have a pretty good idea of how the switch works? Are there questions about this? Okay. I'm going to publish a survey, I think. Am I publishing it? I am publishing a survey. Okay. So this is in Wednesday. Okay. For today, it's like how a switch builds a MAC address table. We're going to take a break. It's 3:05. Be back at 3:14. You might have to refresh your screen because I just published it. Class demonstration survey, how a switch builds a MAC address table? You see it? Two, 3:14. Yes.
Which, are we going to be learning about trace route at all during CNT140?
We are.
Is that going to be in the next layer?
It's in module 13. But you know, trace route's kind of like ping, except it like pings each router.
Well, I know that, so I know that there's two different commands that work very similarly. That's path ping and trace route,
Yes.
but they're used for two different reasons. So
I never use path ping.
that's because normally with path ping, you have to have the IP address.
Yes.
It's used to try and figure out where the failure is coming in with a network connection. So normally with that, you'll have the IP you're trying to connect to.
Oh, cool.
With trace route, you can actually enter, like, say, a website you're trying to get
Yeah.
to. So you can type in the website because usually with DNS, it's got a website attached to that IP.
Mm-hmm.
So you don't have to know the IP. You can actually type in the website. So if you're trying to access Google, you can type in
Google. Yeah.
instead of having to have the IP to connect to Google.
Right.
So I was just wondering if we were going to be working.
Yeah. Yeah, it's in module 13. Again, that's another module like I kind of feel like should be higher because so module 8, 10, 11, 12 and 13 are all the network layer. So yeah. So 8 and it's a real short module because it's about ping and trace route. But sometimes I feel like it should be earlier because we're using ping and trace route in some of our labs and things like that. Let's see, ARP provides two basic functions. Did it not let you pick two? Oh, it only let you pick one? Oh, I don't know. They downgraded my membership.
Marketing is correct, but I only selected resolve and
Yeah, I think it will only let you pick one thing, one right thing. Okay, so when we did an ARP-A, we saw that it had a table and it mapped what to what? Somebody? IPv addresses to what? Okay, so everyone open up your command prompt and do an ARP-A. Open your command prompt and do an ARP-A. So ARP provides two basic functions. So what do you see in your ARP table? It maintains a table of mappings, right? There's an ARP table. Do you see an ARP table? And what does it map? What does it match up? What addresses? Yeah, the IPv4 address to the MAC address. That's what an ARP table does. What does a MAC address table do? Yes, it keeps track of the MAC addresses to the ports. Because remember, what's happening is it's trying to build like a map so it can move the frames around the local area network or out of the router so it can go to a destination, okay? It's got to build something. It's like if you had to give directions to somebody to get to Circle K, you could do a map quest, or you might be like, okay, well, go out of the parking lot and turn left out of, so you're giving directions. Suspected spam. Have you watched any of those where people are like spamming the spammers? Take that back. Fast forward. So remember that fast forwarding, it just looks at the first 64, right? And moves it. When we do this next week, it will be for points. It'll be scored. This one's for participation, but next week will be scored. Just giving you a fair warning now so that you don't try to get a 0 on it. Throttling is referring more to something that happens on ports and interfaces. So it is something, but it's not related to storing in frames. It's not related to frames. Ooh, I just skipped one, did I? I don't know. Hi, Tyler. Okay, good. The incoming port. All right, let's see. Austin, nicely done. Ah, get some money. Second place. Joe, good job. Okay. I want to talk about next week. Okay, so first of all, some of you need to do some studying on this module. Okay, it's a pretty, again, I mean, I know it feels like every module is important, but there's a lot that happens at layer 2, the data link layer. Okay, and we'll be referring back to this a lot, the Ethernet header and the frame. Okay, next week you have 2 modules. Okay, so not only do you need to catch up with module 7 if you didn't do it, you need to do module 8 and module 9. Now, module 8 takes us into the network layer, layer 3, okay? Module 9 is ARP. It's a lot of what we've already done today, okay? I think that this module will make a lot of sense to you because we covered a lot of it. Now, it's going to go over NDP as well, Neighbor Discovery Protocol, okay? And the IP, that's on the IPv6 side. The module 8, it's not a giant module, you know, it's not as big as like module 6 was, but there's quite a bit of important information, and we're moving layers, right? We're moving from 2 to 3 now, all right? We're moving from 2 to 3. Once we start module 8 and finish 9, then 8, 10, 11, 12, and 13 are all related to the network layer, different aspects of the network layer, okay? So just keep that in mind as you start module 8 and 9. Okay. Give me just a second. Okay. So I just published, oh wait, I'm in student view. Just a second. Okay, I just published an assignment. I want us to go in there. Okay, this is addressing, network address, determine equal subnetting versus VLSM. So I want everybody to go ahead and download that assignment, and let's take a look at it. When you have it up, can you just raise your hand so that I know? Okay. Okay, good. All right. Down here, there's 2 tabs. You want to be in the one that says address range. Okay, you want to be in the one that says address range. Okay, does everybody have it? No? Derek, can you show Joel where it's at, please? All right. We've got this network address, 192.168.0.16, and it's a /29. What would the subnet mask be in decimal? if it's a slash 29. 255. 255. Yep. 248. Yeah, I know. I never know whether to go which direction. I agree. Okay. All right. Do we all agree? All right. What octet is the last network bit in? 4. It's in the 4th octet. What's the subnetwork increment, Cody? The subnetwork increment? You just said it. What? What's the subnet increment? 8. Isn't that what you meant the first time when you were giving me the 8? Were you thinking of the subnet increment? Okay. Smarty pants. Okay, how many total addresses? How many total addresses? Okay, 8 total addresses. How many usable? 6. Okay, does everybody have that filled out? Okay. So everybody has that filled out? Okay. So let's go ahead and plug in this 4th octet. We're doing everything in the 4th octet, right? All the work that has to happen is going to be happening in the 4th octet. Okay, so we're going to plug in the 248 right here. And what does that look like over here in binary for the subnet mask? 5 ones. Okay, so like this is on, off, off, right? So you notice how the host bits, we've got them highlighted in blue. This is stuff we've been doing, right? Okay, now to find the network address, we know that all the host bits are actually off, right? All the host bits are off. And we already know what the network is because they told us that it's a 16. So let's just go ahead and plug that 16 in there. And what does it look like over here in the 4th octet? So our network address is 192.168.0.16. So what do we do with these bits? So off, 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 on, off, 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 off. Exactly. Right? Because all the host bits are off with the network. Okay. Now, last week we found the address range and we just looked for the first address and the second address, or the last usable. We did the first and the last usable. This is a really small network, so we're actually going to just find all of them, okay? So the first usable address is obviously going to be the first one right after 16, so that's 17. So let's just plug a 17 in there. Because the first usable address, what's the definition of the first usable address as it relates to the host bits? Turn them all first usable. First usable address. The last one is turned on, right? So they're all off except the last one. Do we agree? Okay, they're all off except, so we're just doing what we did last week. The network part stays the same. These are off, and then this one is on. So what would the second usable address be? If the first one is 17, what comes after 17? 18, right? So 18, plug an 18 in there. And then fill in the bits for 18. Okay, it's 18. What comes after 18? 19. We're just kind of counting, right? Now, the network bits, they stay the same, right? They're staying the same. So what are these last 3 host bits in order to get to 19? So I'm at 16 right now. What do I need to do? What do I need to turn on over here? The last 2? What comes after 19? 20. So these are the different addresses we could use on our end devices. Are you filling yours out, George? What comes after 20? 21. Okay. So once you get to the end here, don't work ahead. Like let's get through these, and then we're going to work on the next ones together. So if I got 21, and then the last usable address, that's going to be 22. And the last usable, we know all the host bits are on except the last one. And then finally, we're at the broadcast address, where all the host bits are on. Okay? So let's just look at this. So I want you to just look at this, okay? So we're just looking at this. And this is a nice small network so we can see what we're doing here, right? And notice, is this like every single combination possible with the 1s and 0s? That's all that's happening. Now, if you have like a /16, that means that we have 16 bits of on, off, on, off, on, off. That's really hard to keep track of. But with this nice small network, we can see that. We can see that, okay? Now, does everybody understand what we just did? Okay, and now I have those addresses that I could do end devices with. Now, this is the first network that we started with, correct? Now, if I wanted to find another network, because I have another department, how do I do that? What do I do right here? Right, I know that if I look back at the information we gathered in the 4th octet, right? I'm in the 4th octet. My increment is 8. So I add 8 to the 4th octet. So 8 plus 16 is what? 24. Now, look at this. Here's our broadcast. What number comes after 23? 24. So whatever the broadcast is, the next address will be the network for the next network. So if you think of it, we're just counting, right? We're just counting. We're just counting. If I have, 9 cupcakes and I give you 9 cupcakes and then I go to the next room and I start with the number 10, right? We're really just counting. We're just counting. So let's fill that in. Okay, we know that our next network is the 24 because I added 8 to 16. My subnet mask is the same. My subnet mask is still 248. This is called equal subnetting, where every network is exactly the same size, no matter what I need. It's just the same size. Okay? Now we're going to do the same process with this network for customer service. Okay, what comes after 24? What comes after 25? 26, okay? So we're just figuring out the addresses that we can use on this network. Okay, so we're going to fill this one out. So make sure you get the subnet mask. Right, we got the subnet mask, and then we get the network. All the host bits are off for the network. Then we're going to find the first usable. Okay. So once you have found the network, remember all these network bits, they stay the same. We're only able to manipulate host bits. Right? We're only manipulating host bits. Now, when you get to the broadcast, again, just sit tight. Please don't work ahead. So 26, 27. Okay. So our network was 24. Remember, that's like the umbrella over everything. And then the first usable, I can assign that to my what? What would I give the first usable address to? The default gateway. Does it have to be the first usable address? Doesn't have to be. It's just a rule of thumb. And then I've got 26, which I could assign to a computer, 27, maybe I assign it to a printer. These are the addresses I can use for my small business. Again, notice we're just counting. Now, what do you notice about the first usable address and the broadcast? Are they odd or even? They're always odd. Okay, the default gateway and the broadcast will always be an odd number. And the last usable address is always going to be an even number. It's just the way it is, okay? It's always going to be an even number. So that's a quick little way you can do a test. Okay? Now, if I know that the broadcast is 31, what's the next address going to be? And would that be the network address? It would be. The network comes, the next network comes right after the broadcast. But I also could have used the little trick where I add 8 to 32. So what's my, or 8 to 24, excuse me. I can add 8 to 24 to get 32. So there's a couple different ways we can find the network address. What's my subnet mask? 255, 255, 255. 248, it's exactly the same, right? I've got a new network address, which we said is 32. What's my first usable address? 33, right? 34. 35. And what are we doing with these host address? We're just manipulating them. We're just flipping them on, flipping them off so that we can get every combination of addresses. And then finally, we've got a broadcast address of 39. Okay, does everybody see how this is working? Yeah? Okay. Messing this one up. Okay. So we're just more or less counting, right? And then we're manipulating the bits. Okay. So I want to end with this. Okay, this week on Friday, you have a video due for VLSM, variable length subnet masking. This is equal subnetting. The networks are exactly the same size. Okay? Variable length subnetting is when we take into consideration that the networks might be a different size. Maybe I need 20 end devices on LAN A. I need 10 on LAN B and 3 on LAN C. Variable length subnetting, not equal subnetting. Okay? This, if you click on the VLSM and address ranges, the next one at the bottom, okay, This is variable length subnetting. It's exactly the same, it's just that each network is a little different in size. So LAN C, we need 14. LAN A, we need 6. LAN B, we need 2. Okay? So you're going to go through that same process that we just did, but you're going to do it for variable length subnetting. My advice is that you watch the video first and then work on filling this one out. And you can see that some of them have already been filled out for you just to kind of help, right? Like this one's already filled out. And then the ones that are in yellow, you got to get those in there. This is homework. This needs to be completed when you come to class on Monday. Okay, this is homework. We did the first one. We did the address ranges. This is due on Monday when you get to class. Not once class is started, but when you get to class. My advice is you watch the video first or do it along the same time, okay? And if you get stuck, just remember it's pretty much the same thing. It's just variable length instead of equal subnetting, okay? All right, so you have a lot to do this week between now and Monday. All right. Have a good weekend. I'll see you all on Monday. I'll send out a reminder that this is homework, okay?